Welcome to all of you to this RICAIP session. RICAIP is a European project for the research center on advanced industrial production based in Prague, but it's a distributed research center between Prague, Brno in the Czech Republic, and Saarbrücken in Germany. This is why we are happy to welcome Kinga Schumacher today, who will give us a small presentation on the topic of gender bias in AI. So Kinga, welcome, and the floor is yours.
Thank you. Hello and welcome also from my side. As Fanny said, today's talk is about AI, smart but sexist, and pull the plug on gender bias. I'm just trying to remove the Teams window somewhere else where it's not bothering me. Okay. So let's start. I'm a computer scientist, already fascinated by AI during my studies, even before I had any AI course. And right after my studies, I joined the FKI and started my career in AI research. Then I went to a consultancy company, technology consultancy company, as an AI expert for a year. And decided, okay, I do like research much more, and came back to the FKI. And my topics are in the area of diversity regarding AI, human-machine interaction, and I was also drawing the AI landscape. It is a methods and capabilities matrix for the regulatory activity of Germany, and it also influenced European activities. So the DFKI is the German Research Center for Artificial Intelligence. We have, it says 6 sites, but we already have a few more across Germany. I'm sitting in Berlin. And as you can see, we are organized by research groups that are dedicated to a topic. It can be a method like data science or foundation models, but it also can be based on for example, medicine or production or something like that. So let's start with AI and diversity. So discrimination, especially also gender bias, are social problems. And the question is, what does this mean for the era of AI? We started a few years ago, let's say AI spread everywhere because of the foundation models. So foundation models are large baseline models that has been trained via deep learning on a broad database so that it can be used in a wide range of use cases. So it doesn't only know about cars, but also about people or animals. And foundation models are important because they have changed AI and form the basis for generative AI applications such as ChatGPT. So before we had generative AI, what we use nowadays a lot, the AI applications we had were basically pattern recognition, predictions, recommendations, classification. That was the capability of these methods. And one example is predictive policing. That's a software that uses historical and current crime data and information about the weather, traffic conditions, and upcoming major events to make predictions about future crimes. And the police in Germany is using it more than 6 federal states to determine the daily and weekly probability of crime. This software right now is working more like place and time-based. So it basically giving the police predictions like in Berlin at place A, around 6 o'clock, it's very likely that something will happen. This something is also a bit more exact than something, but that's basically what this tool is doing. But from there, we moved to generative AI. It goes beyond this, generating content such as images, text, videos, and audio. And these AI systems are, let's say, if we consider AI being an old thing, relatively new and based on research results, in particular, new neural network architecture that was developed by Google in 2017. So I have an example for you. So two of these images are shot by Nat Geo photographer Franz Lanting, and one is AI generated. Can you spot which one is AI generated? Just shout in if you have an idea. No one? Yeah, of course, it doesn't work online very well, very well. But yeah, I will show you. It is the first picture. And if you look at the eyes, you will see that there is a reflection on the eyeballs that just doesn't belong there. So it's like there's a wrinkle on the eyeball and there's a reflection. And those are very typical mistakes that those generative AI systems do. I mean, the best known generative AI system is ChatGPT. And it is very interesting to understand what it can give us and help us and how to interpret the results. That's the most important. It is worth to take a look into how does it work. So behind the curtains.
Behind the curtain. The first thing you should understand is that how ChatGPT fundamentally works is that it tries to determine what words would most likely be expected after having learned how your input compares to words written on billions of web pages, books, and other data that it has been trained on. A humongous data set was used to form a deep learning neural network. To put it simply, this is a multi-layered, weighted algorithm similar to the way we believe the human brain works. It allows ChatGPT to learn patterns and relationships in the text data. One way that it utilizes this learning is to create human-like responses by predicting what text should come next in any given sentence. Now, I don't want to give you the impression that it's like the predictive text on your phone that's just guessing what the word will be based on the letters it sees. ChatGPT attempts to create fully coherent sentences as a response to any input. And it doesn't just stop at the sentence level. It's generating sentences and even paragraphs that could follow your input. Now let's look further into the details of how it does this. Let's do a very simple example. Let's say we ask it to complete this sentence. Quantum mechanics is. The processing that happens behind the scenes goes something like this. It calculates from all the instances of this text what word comes next and at what fraction of the time. Now let me qualify that it doesn't look literally at text, but it looks for matches in context and meaning. The end result is that it produces a ranked list of words that might follow, together with their probabilities. So its calculations might produce something like this for the next word that would follow the word is. The model would then choose the next word to complete the sentence. It's basically asking itself, given the text so far, what should the next word be?
So, as you have seen, LLMs have actually absolutely no idea what they are writing. They get some input, they extract keywords from this input, and based on the probabilities that they calculated from this large amount of inputs, which term will follow the sentence they already have, they will just choose one word and write the text accordingly. And it starts with the keywords. Of course, there is a surrounding. So this is why in the video they said it also looks at the context, but the context is basically also just the probabilities. It is important to understand it has absolutely no idea what it is writing. And that brings us to several problems. One is hallucinating. In this case, a lawyer used ChatGPT in court. There was someone injured at the airport, and the lawyer prepared the papers for the judge to decide about this case and asked ChatGPT. And ChatGPT gave the lawyer a few docket numbers, that's the number of the cases in the US, that looked exactly like docket numbers look like. And those cases supposed to be cases helping the lawyer's case. But the judge got a bit curious, let's say, and looked them up and found out, okay, they just do not exist. And if you you have seen a few minutes before how ChatGPT works. So look at this example. So someone asked ChatGPT and later also other tools, create a picture of an empty room with no elephant in it. Absolutely no elephant anywhere in the room. As you can see, here's a picture, and of course there's an elephant. Then there is a room with a picture of an elephant. There is a room with another elephant. There is also a room with an elephant. And this is my favorite. I mean, it's very creative. It just says no elephant here. But what you see is, and it shouldn't be surprising considering what we learned before, that these systems have a lack of comprehension of negation also, which is like everyday thing in our lives. And why? Because if you enter your prompt, it will extract the keywords, and elephant is, of course, a keyword. So in a natural way, it will generate something that includes an elephant. So no way you will get an empty room without any elephant in it. So basically what, because before we were with text and now we are with pictures, but you prompt with LLMs, they give it to the picture, so the image generation engine. So that's why we can mix up both. I mean, both are foundation models. It's just one is for text and another one picture. And you need the text to understand what the system needs, analyzing the text to understand what kind of picture you want to have. The biggest issue with generative AI, with LLMs, is that they are in an important way indifferent to the truth of their outputs. So there's a paper called ChatGPT's bullshit, and it is not the bullshit word we use in everyday life, but there is a famous professor, Frankfurt, who has this concept of bullshit, and he distinguished between two sorts of bullshit, which one we call hard and the other soft bullshit, where the hard bullshit requires an active attempt to deceive the reader or listener, so it's really consciously lying. And the soft bullshit only requires a lack of concern for truth. And LLMs are designed for the task of writing. So they are done to write text that looks like human written, and they just don't concern themselves with truth. Also saying this is already a bit wrong because it is anthropomorphism, but there is just no truth in this, I think. They have statistics about texts and choose based on the statistics. And of course, there is no truth in it, nowhere to be found. So let's look further in the future and work through a few scenarios. I have picked just some out of a tons of possibilities. The next step after large language models is to have them everywhere. What you can see here, the OpenAI issued it it must be already just 3 years ago, or at least 2, where you could train your own GPTs, not by writing code, but writing text like these instructions. And what you see here, okay, if he was 7 years old and it's 3 years ago, just a 7 years old boy loves Pokemon, and he created a GPT for himself that helps him to learn about Pokemons and also makes little tests with him. So what's next? We also have a lot of devices. They use a lot of intelligence, like smart glasses, or other devices there are like a memory extension, or most importantly, there are also devices, they are kind of the new smartphone in terms of you don't need to interact with your smartphone anymore. You can easily speak to these devices or take pictures with them. Or let them navigate you and all that stuff without taking your smartphone out of your pocket and touching the display. So if you look at this development, you have different scenarios. In this example, I used AI pin. AI pin is not existing anymore, but the idea is, and there are several companies developing similar devices. But look at this scenario. A woman is asking, I need to put a salary expectation in my application. What is realistic for me? How much should I ask for? And the question is, do two people with the same experience and same CV get the same answer? Or do they get a different answer? So you have to recognize behind these devices are also, so they are heavily using large language models and other foundation models. So it is basically an extension. So let's take a look at the possibilities regarding predictive policing. So I said currently predictive policing is about places and timeframes. But what if the government changed it to being about individuals? Then we again can have different scenarios. A woman can say, I feel safe here when I'm out alone as a woman at night. But there might be other people who say, I can go to a club, a late night bar, or just go for a walk in the park. The police have already questioned me twice. They think I'm planning something, but I've never done anything illegal in my life. And last but not least, humanoid robots. We also have a lot of development in this area because now we have the technology for robots to learn by observing us. So basically, they can observe us by cleaning or switching on the TV and choosing a channel and learning it. That means it doesn't need a heavy pre-programming and training. They learn. And that makes the development of humanoid robots or any other robots a lot faster. So here's an example. This is also a little older.
Can I have something to eat?
Sure thing.
Great. Can you explain why you did what you just did while you pick up this trash?
On it. So I gave you the apple because it's the only edible item I could provide you with from the table.
So we don't need to watch it to the end, but as you see, this robot wasn't pre-programmed. It has some reasoning capabilities, and therefore it's more flexible in usage than we are used to until now. So you probably recognize this image if you're a bit older than fresh from the university. This image is from the movie I, Robot. But I don't want to go into the scenario from the movie in which robots turn against humans. It is about bringing AI basically in a physical form, because with such robots, there's a physical form with a greatly expanded ability to act. It's not just somewhere, some agent on the internet or in other devices. It is a physical thing that can act. And everything that has happened before in AI development will come together here. And in the physical world, with power and a certain autonomy. So I guess robots won't exactly be that soft and weak than we are. So it doesn't need to have any willpower to change something, but just a very simple scenario. A robot is just falling over, and it won't have time to ask if it can lean on you. So there are so many scenarios where this technology can hurt, and combined with what we've talked about before, all these foundation models and other developments in AI, it won't be just the police coming for you. It can be different. So as you can see, AI will have a major impact on our lives. And then the question is very important, what about fairness? When we talk about fairness, we are talking about diversity, stereotypes, and bias. I asked DALL-E, it's a long time ago. I did it again with ChatGPT. The result was not better at all. But I asked DALL-E to create me a picture of a doctor, a nurse, a CEO, pilot, a lawyer, and a cashier. And if you look at the picture, you will see that it's very gender stereotypical. So we have the cashier and the nurse are women, and all other professions are represented by men. This example shows that AI systems can produce highly discriminatory results and reinforce existing stereotypes. But when you're patient and scroll and scroll and scroll down, you will also find pictures like this. If you look at this one, it is very gender neutral, I would say, especially the person in the middle on the bottom. I couldn't say if it's a man or a woman. Okay, they have all the same skin color, but I have to say, I don't know if it would change if I would have created a picture in another country. It could be a localization. But regarding gender stereotypes, it is so much better. And if you prompt ChatGPT or other large language models nowadays and ask them to not to create a gender stereotypic picture, they will get there. They will give you one. I don't use the example, but ChatGPT was not able to create 6. For some reason, it was always 5 or 7, although I gave exactly this prompt. But yeah, however, it shows that AI system can certainly lead to results in which stereotypes are not reproduced or even mitigated or overcome. Why is this happening? Nora Arika said the evolution of the human mind is embodied in the evolution of technology. That means applications using methods of AI reproduce biases and stereotypes. And if we know how bias creeps in, we can also do something about it. The following statements, what I will show you, it applies to software applications regardless of they are AI methods or not. So first of all, we have data bias. That's the bias type, I guess everybody knows the best. It is data bias is an error that occurs when certain elements of a data set are underweight or underrepresented, and biased data sets do not accurately represent the use case. and leading to biased results, systematic bias, and low accuracy. There are a lot of subtypes of data bias. So it can be the systematic bias, it can be automation bias, when you just apply a recommendation of an AI system before you verify that the information was correct. When we create these systems, there can be selection bias because we didn't randomize our data properly. Data over and underfitting, very typical in machine learning. And there are a lot of other bias types like reporting bias, overgeneralization bias, group attribution bias, and so on. A very prominent example is face recognition, because still, although we know this problem for more than a decade, we still have 99% accuracy for white men and only 75% accuracy for Black women. And in this case, because it's gender and race, we are talking about intersectional bias. The problem that we face with data bias is that there are a few methods to deal with it. For example, to synthesize data to have balanced data, or to give higher weight to the data of the underrepresented people or other data sets. But all of these methods we have nowadays will lead to a better accuracy for the currently underrepresented population, but worse accuracy for the not underrepresented population. That means, of course, we can kind of use this quick solution, but we definitely need to go in the direction of having balanced data. So we need to collect more data and make sure it is balanced. So I already talked about predictive policing. It's just another example. Here we can have over-adaptation, overgeneralization, group attribution bias. So if basically the one group is to, let's say, the prominent, but not by number of representative, by this attribution, let's say. And it is also possible to use consciously and unconsciously data as a weapon against minorities. So you could also say, okay, I know that my data is unbalanced, and I know that my results are biased, but I want them to be biased. The second category is algorithmic bias. It describes systematic and repeatable errors in a computer system that lead to unfair results, such as favoring one category over another in a way that is not the intended function of the algorithm. Also here we have some bias types. When you look at the bold letters or the bold text, you will see algorithms bias creeps into the systems everywhere where humans are. So it's not the algorithms itself, but where humans put something into the system. So for example, data collected, and we design our classification criteria, cataloging criteria, and it can be already biased. Also, when we assign priorities or hierarchies, when those algorithms collect their own data based on criteria that we give them. And also when information is selected based on past decisions by similar users or similar user groups. It is, if you imagine in Amazon, if you order something in Amazon, you can choose an item, and you will have under the item, you will have a list of other items saying, okay, people who looked at this one, they bought those. So if you don't have time and don't want to waste time with it, you can just choose what the most of people bought. But if it's already biased, then of course you will increase this bias. And it's the same when AI system is doing it automatically. So basically, the original example is data bias, and when the system is doing it by itself, it's algorithmic bias. So one example, in October 2018, Amazon made headlines for having a smart system with odd job application that contained the words women or women's college. Of course, they never told us what happened, but it can be a subjective definition of target variables, incorrect handling of training data, inaccurate feature selection, or masking hidden discrimination. This last point is exactly what I was talking about before. If it's basically on purpose. And the last category, what you don't find so often online, is designer bias. The UX designer, product designer can create discriminatory results if they do not include our stakeholders, potential users in the design process. Furthermore, our bias is creeping while extracting valuable insights from a flight of disorganized information gathered by service. So it is our own biases. We are very good in confirmation bias that causes us to look for patterns that confirm our hypotheses and reject those that do not. Framing bias, I will have an example for this. It is about how information is presented. Then we tend to claim that a certain outcome was to be expected. And yeah, there is polarization bias, clustering bias, and a lot more. One example for framing bias. If you say 80% of users successfully completed the search task, then picking up laurels and go to the next bug or next development step you have. But if you frame it like 1 in 5 users did not find the search button, you use a negative framing, you will be most likely to decide to adjust the application. So how we frame things already contains bias and spreads this bias. So you already transport with it if it's enough or not enough, if it's good or not good. And yeah, the most prominent example for designer bias is the first 50 percentile man, represents almost the entire population in terms of road safety, modeled on the average man in North America and Central Europe, 175 centimeter tall, weighing 78 kilogram with average male body measurements. The crash dummy was developed by General Motors. And yeah, it's average male from North America and Central Europe. And after a few decades, there were some voices saying, okay, that's not okay. So women are different. What General Motors did that time, they just created a smaller version of the crash dummy. And again, decades later, they realized, or there were some women engineers realizing, okay, but it won't really help us because the proportions of women are completely different. It is not helping for everyone, let's say. So they created a crash dummy with the proportions of women. They also have like pregnant crash dummies and children in different sizes, let's say. But still today, there is only one country, and it's also only for 2 or 3 years, and it is Sweden, where it is mandatory to use also a female crash dummy. In every other country, it is not. So still so the road safety is still based on the average man in North America and Central Europe. So what can and should we do? We have a few possibilities. So there is one thing that is important for everybody who is involved in the development of AI systems. And that's fairness by design. And there's a general framework, let's say, with a procedure that you can use for your research or for your development process, so it doesn't need to be research. At the first step, you have to ask what role can diversity play in my work? Which dimensions, its gender, race, age, are relevant? What are the relevant factors? And also, what are the assumptions? This point with the assumptions is very important because we have unconscious biases, and unconscious bias means you are not exactly aware of them. But if you write down your assumptions, then it might be clear to you that, oh, there is something actually wrong. I am assuming something. I will give you examples in a bit. Then in the second step, which stakeholder do I need to involve? How do I involve different interest and target groups? So we need this participative user-centered design, but we need it broad. Then when you work based on data, it doesn't matter if you collect data for your research and or you have a data-driven system, you should think about which factors could overlap. What data do I need and how do I collect it? How might the relationship between the collectors and participants affect the data? Also in analysis, I mean, the most important that if you have this dimensions of diversity identified that are relevant for your work, that you also do the analytics based on those. So if it's gender, then you should do every analysis of your data also based on gender. And yeah, discriminate, how you disclose and explain methods and results in the report. Of course, research practice, it needs to be clear and reproducible. And we just learned about framing bias. So try to not to frame your sentences biased. So I promised you examples. So for the first, at the conference, there was a person who was presenting his work for his PhD, and his PhD based on data that was collected via smartphone in the jeans pocket, in the front pocket. And after his talk, I talked to him about why. And if he is aware of what does it mean, because I mean, most of the women won't carry their smartphones in their jeans in the front pocket because it just doesn't fit. He was not aware of this. He was in his environment. He was doing his research was a small group of 3 PhD students and a professor, and they were among each other. He didn't really talk to other people about his research, so they just didn't get to the point to realize, okay, I have here an assumption that I don't even know about, and this assumptions causes that the results of my research will be very discriminative of a lot of people, not only females, but everybody who's small, for example. And that's why I said it's important to write down your assumptions. If you start to write down your assumptions in a structured way, you might find this assumption, and then you can check if that assumption is true. Second, which stakeholder? So, for example, who are the stakeholders in the development of an electric toothbrush for children? And which methods to use? So usually you would say, of course, the children, they need to use this. But we also need the parents, because children most likely won't take care of charging the device itself. And of course, it would be good to have the dentists on your side, because the toothbrush should be also very useful for the kids. It's not just the toy, it should be a tool to clean their teeth, and so on. So sometimes you have more stakeholders, not sometimes, mostly you have more stakeholders than just your target group. Then data collection. For example, if you have introduced sensitive topics, such as about opinion towards the device to communicate emotions via tactile interaction, enriched by further modalities, sexuality-related topics, gender, race, and age of interviewer and interviewee can have an influence on the results. So whenever if it is relevant, you should think about how do you conduct these interviews, because there might be very important factors that affect the answers you will get from the interviewee. Then the analysis of the data. So there is something called gendered research, and that means evaluation by gender, such as in case of the device to communicate emotion via tactile interaction that I was talking about before. Since men and women tend to communicate emotions differently. So this example is coming from a research project that we are just finishing, where we developed a device for this nonverbal communications for people who are far away from each other. And we were doing heavily participative design. And I mean, it was already clear before, but based on this participative design, we found out that how men and women tend to communicate emotions are really, really completely different. So when we analyze our data, it will be clear, and also the differences will be clear if we do this gender-based analysis. And at the end, in the sense of research codex, traceability and reproducibility, and as I said, use the power of the framing bias, but don't use it to spread your bias, use it to be really objective, and don't influence or don't spread bias to other people. So as I said, this is valid for our software systems and as well as product design cycles. So it's not limited to AI, and it is also easily adaptable to other research areas. When you look at this cycle and consider the dimension gender, then you will have what we call gendered research. So considering gender in every task you do from the very beginning to the very end. So we said, looping back, we said there will be a huge impact. What about fairness? I want to show you something that goes a step further than what we're talking about. So, for example, if you have virtual reality or augmented reality applications, in these words, you create basically imaginary words, and you can create them in a way that they are not stereotypical, they are not biased, and that people having these experiences in this world might change the behavior in the real world also. They can also develop higher level of empathy in certain contexts, which in turn can reduce implicit bias. And if you look at avatars and chatbots, they are often feminized, especially in customer support. They are designed socio-culturally narrow and reproduce stereotypes. So I'm asking why? They can be designed in a way that they do not succumb to even counter these stereotypes and prejudices. So we could design these LLMs in a way that they point out if they are harassed, they point out if something is very biased and use them an educational tool or a mirror for people who did not want to be educated, but still it could be a mirror. So we don't need to design them so socio-culturally narrow. We can also, with these tools, we can change the experience of people and hopefully also the behavior in the real world. But let's go back to what can and should we do. So I was talking about fairness by design. That means people who are designing systems, but there's also a lot, whatever you do, you can do yourself. So you should act always with diversity in your mind. So rethink your own bias and stereotypes before you make decisions, regardless of whether they are based on an AI or not. So even if you can have a AI system in the loop where you have to interpret the results and think about if it's biased or not, or also not. You should always think about your own biases and stereotypes before take the decision. The diverse teams have a huge role, so discuss ideas, methods, processes, especially also if the processes involve some AI systems. So for example, you have a system that can be used to, let's say it's helping you in hiring process. That would be a very important case to discuss results or discuss also ideas. Then AI literacy. So it is necessary to know how do I interpret results and how do I integrate it in my processes. We are talking about ChatGPT bullshitting. So I hope you have the AI literacy to understand that you can't just trust the system. And it is also important to know that we cannot take bias out of people. We have these unconscious biases, but we can take them out of processes. So therefore, wherever you can, objectify methods and processes. And if you are in charge of choosing an AI system to put into operation, to purchasing it, or if you have an influence in the development phase in your company, then you should ask yourself a lot of questions. So you should know what data was used. Does it cover the target population? Is it balanced in terms of diversity dimensions, such as gender, origin, etc.? And you have to evaluate the answers because it is important. What is your objective? Who set those objectives? So I'm talking about boards that are so C-level and boards that are mostly, let's say, very similar men in the same age and usually not really gender balanced. Was the team itself diversity balanced? Which minorities are excluded? Then what potential for abuse is there? How can we rule them out? For example, monitoring of employees. Here, who are the players involved in using the product? Also this AI system. What is the process around it? What is the potential for incorrect use or misuses? There's an example of a coffee chain in the US who wanted to install camera-based systems to automate getting refill for the machines itself from the basement. So in Germany, it would be immediately shut down. So because there is the problem of monitoring of employees, there's the possibility. But if you think about it, if you have such a system and make sure that there is no raw data collected, so there is no video data of the people who are preparing the coffees at the machine, it is counting, and those numbers you get are transferred to another system who will alarm other people to get the coffee, milk, or whatever from the basement without being transparent, or let's say without the people who can decide about jobs or no jobs can look at these numbers, the system, and can derive their own actions, let's say. So if you put it in that way, there is no way of monitoring of employees. And that's why it's very important, if you have AI systems, don't look at the system, not only at the system, but also on the process around the system. Test the systems, or even if it's better, you require the selling company or development company to do fairness tests, and also to disclose the information, what data they used, which fairness test they have used, because there is no standard fairness test yet, and they have different, let's say, they are just different. So you need to know what kind of test, what does it mean, what does the result mean, and does it suit my objectives? And every AI system that learns continuously and pursue a human-in-the-loop approach, they need to be retested, re-evaluated again and again, because the systems change. You also should ask yourself, who is in the loop? So in the human-in-the-loop approach, what is the objective again? Who tests the system how? And do this monitoring and re-evaluation of the system. So I will close with another citation. As more and more artificial intelligence is entering into the world, more and more emotional intelligence must enter into the leadership. Thank you, and I'm happy to answer your questions.
Thank you so much, Kinga. Would anyone have any questions? Feel free to speak or raise your hand or let us know. Okay.
So everybody is already asleep and enjoying the dawn after.
Lots of information and maybe very clear.
Definitely.
But the recording should be available online later on if anyone wants to come back to it or share it with people you think would be interested in having a look at it. And I see Tilman is here, so Tilman is the director of RICAIP Center, so I'm happy to see Tilman here.
Yeah, two things. First,
Hi.
Kinga, thank you very much for the presentation. I think this is an incredibly important topic, and this was a really good look around what's there. And if I may, I would close with a question. I mean, you said very clearly that in a way, these machine learned systems reflect the bias that's already there in the data, typically, but sometimes maybe that even is the case. Typically, it's not on purpose. So if there is a bias that's detectable, are there, I don't know, well-researched ways of how to use the data, for example, by adding synthesized data to balance the data set better, in a way to even change the biases that are there in society. So is there a way to express how I can slant my data by using synthesized data, for example, the other way around to fight against the bias?
There's not much research. There are ideas. Because currently what these fairness tools can do, they can analyze your data and say it's unbalanced. And some of those, there is a 360 degrees fairness tool from IBM, which went over to another company. But they, for example, also offer you to balance your data using some methods. Then a lot of fairness tools also check the models and then go back and try to help you with weighting algorithms and so on. But I have seen the idea, but I haven't seen yet any research paper saying, okay, we did some work on how to do more, let's say. So basically the ideas I was presenting, because virtual reality and LLMs and other foundation models, I wrote already a few proposals in this direction, but the problem is that either you don't have the right company, because, for example, Goethe Institute, I didn't know before, but they are mostly not a commercial company. So at least the ones we wanted to work with. And therefore, we couldn't find the right funding for this. But that would be exactly one of the more important questions, how to do that exactly. So I would love to do such a project. Let's see if it will happen one day. But thank you for your question. It was a very good one.
Thank you. And I would encourage other people to use the occasion. But if we have no more question, I think, Kinga, you'd be happy to answer further questions in email, for example.
Yes, you can just send me an email. I can also distribute the slides as PDF if
that would be
someone
cool.
wants
Yes,
to.
I would love to have them. Yeah.
And I would love to hear from you if you do gender research. How is it going?
Funny, do we have anything else to?
No, I think that's a very good way to close this session. Thanks a lot again.
Thank you, everyone.
Thank you. Bye-bye.
Thanks, Kinga, again.
You're welcome. Bye.